Hello, everyone. Here I would love to introduce you the use of Midas J and JEN and general. I think that means Midas for general structure design and analysis software uh, that we are going to use for steel design as well as for concrete design. And here, as you can see here on the screen, there is a example that we are going to do using that software. And this is a prod truss showing here on the screen. It's a pretty simple structure with some members on the outer surface of the truss over there. So there are also some smaller members as the interior members. And we are going to apply a load at the very bottom chord over there so that we can tell if there is any, but definitely we will see some bendings for the bottom chord or some bendings for the top chord and some axial forces in the smaller members in the interior panel over here. So we will use the Midas general. No. So the geometry is pretty straightforward. So we have the total span, we have the spacing of each panel, like 15 feet. So we have how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12, 15 in the horizontal and 2 in the vertical directions here. So that's the geometry of the truss. And one side is pinned, the other side is loader supported. And so some other information we need, we know this will be steel, right? 29,000 and the steel here. Just use the darker. Just use red. So the steel is 29,000 here, and we have the area for the vertical and diagonal members, because the diagonal members are just truss members, so no moment of inertia is needed. And the side girders has a area as well as a moment inertia because they are supposed to work as beams there. So we'd better to input moment inertia. Otherwise, if we model them as beam, if we do not input the moment of inertial value, the software will give us some error message over there. So that's the background over here. So analysis is pretty straightforward. We apply the load at the bottom here for the bottom chord will be under loading only. So that's the background of this analysis problem here. Now let's go to Midas. So this is a Midas general. As soon as you install the Midas on your own PC, unfortunately, you can only install Midas on Windows PC because it does not support Mac. But there are some ways for you to run Midas on Mac. Probably you have to run a virtual machine that comes with installation of Windows so that you can run Windows on the virtual machine on your Mac. But I think Windows machine is the best option in this case. So as soon as you open, after you install the Midas and you activate with the code, activate it with any code that you got, you should be able to open it. So there is a start page over here. So now let's go. So this is for very wonderful software for structural analysis as well as design. And I think it's industrial level software, and it's I think it's in the mainstream software over here. Okay, so let's go. So we need to open a new project, right? So we just open a new project. Okay. Oh, this is not working. Anyway, we can. Oh, Looks like mine. Okay, it takes a few minutes. Something wrong. Oh, it's not responding well here. Yeah, my computer is slow. I don't know what. Okay. Okay. As soon as we open a software, open a new project, you will see a very clean window over here. So that's we can create the truss and save it. So we go to the structure. We just the way we use this software, we start from the left corner and move from left to right. So we create a model, apply the support, and do analysis, results, so that we can get everything done from left to right here. So for view over here, there are a lot of icons here to change the view over here. I'm not going to do any changes of the view from here right now, but I'm going to show you later. So let's go to the structure. So firstly, we need to select the structure type. Select structure type. So basically, if you go back to the problem that we have over here, that's a two-dimensional truss. Right? When we start from the simplest case, two-dimensional truss. So we will not use the 3D type. If you create the truss as a 3D type, you have to consider more inputs here, so that would be too overwhelming as a first part of the lecture on the use of the software. So we're going to use the two-dimensional, right? So either XY or XA. And so I'm going to use XY here because um, later you will see using XY would be more efficient because the Midas only allows us to create a grid system in the XY plane here. So could be more interesting. And another thing is that the unit system, right? The unit here is in meters and seconds. So we're better to change the unit too. So we just click OK. We can change the unit later. We can go back to the unit system. So there is the tools and the very right side. So you can change the unit system to feet and pounds. Let's change to feet, or probably we got to start from foot and the pounds over here. So we just click OK. So everything is in foot pounds, and you can check the unit system at the very bottom of the window here too, right? So as you can see here, very bottom and close to the right. Okay, so that's the pounds and the foot. So we have already selected the structure type as the XY plane, and then we would like to create the model. We can show the view in only two-dimensional, right? So we can have a display viewpoint. So since it's XY, so it's gonna to XY, or you can show the view somewhere over here. So from top up here. So now we create the grade system. Grade, we will change create grade system here. Oh, oh, it's not showing here. What better? So we create a grade in the structure here. So define line grids. So we define line grids. So there is a window for us to define the grades, because we do need the grades to help creating the geometry here. We can close add. So we can have this is the grade system. We can change grades. We can add any X, Y lines. We can use some simple commands, as you can see here. So such as we have 12 at 15 feet in the X direction, as you can see here. In the X direction, we need how many grades? We need 13. So we have 12 spaces, so we need 13 grades here. 13 instead 12. So 13 grids here, and similarly for the Y, we need 3 at 15 too. So we have we apply, so we have the grid system here. So I'm gonna show everything here. So it to make sure everything's fit. Oh, okay. I think we have. Oh, oh no, I don't. No, do I have all the grids yet? No, it will just auto fitting. Okay, okay. Yeah, it may take you a while to figure out. So we are done over here. So then we create, we have the grid system, so we can create the geometry. So we move to the node element. So here we do not need to create any nodes. We can just start from the grids, right? Grids here. So we have how many grids here? Oh, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so basically it looks like we do not need the last one. So we create the element. So if we create element here, we have the option to create element. There are, since we work from the graphical window here, we do not need to take care of the load number or element number. The software will do that for our use automatically. So here we will create a general beam or tapered beam here, because for the outer one we will have a beam, so we can start from here to the to here, and we have one here, I believe, and from here to here. So we can just create the outer. So we're done with the side girders. So and then we need the interior ones. Let's do a quick check. The interior ones, we have some vertical ones. Vertical ones starting from here. We just create all the vertical ones firstly. So for each of them, we need the vertical ones. So we create the vertical ones would be truss members. So we can change that to truss from here to here, here, here. And create the truss one by one, or there are also some advanced tools that I'm going to show you later, but very similar. So that's the vertical ones. And then let's say any horizontal ones. We have the horizontal ones in the middle here and on the sides here. And so this keep in mind. So we have here to here. Is that correct? Okay. Okay, just right in the middle. Right in the middle, we have a one, and then we have a side one. It's a side one. Okay. Another one here to here. Horizontal ones. Okay. And the diagonal ones, we have this one. Okay, just make sure we have the. So basically, there is some pattern over here. So we have diagonal ones here and the diagonal ones over there. We have diagonal one here, the here to here, here to here, and do we have any? Okay, one here to here. So that's it. So that's all the diagonal ones. Partial of the diagonal ones. So this case, as you can see here, this is the symmetrical one. So pretty much we can just use the mirror to create another one. So here we can use the mirror. We select then we want to do the selection here. Okay, it's better to Okay, so Truss example. Save it, right, before we move too far from here. So we wanted to use the mirror, So we select. So here, there is a window for us to do the mirror. So firstly, we wanted to select some of them, and then we wanted to have the reflection plane. Reflection plane should be YZ, right? And at the middle, that's 90. Right? So that's 90. Should be 90 here. And then we apply, and we now select element. So we can select element. So there is a way, and there is a right below the main row of icons. We have the selection, and we can select or select one by one. Okay, just select one by one. Select this one, and then we want to press Control to select those ones. So we want to mirror them. Apply. Okay, they are mirrored. Okay. Okay, and also we can make copies there. Make copies. So diagonal ones. Basically, we will have a copy for the second row here. Second row here. Make copies. So here we have translate from the x direction, and so by 2 parallels, so that's 30. So the dx should be 30. I'm not selecting anything, but we can select from here. I'm going to select, select this one, and this one. So we need time. So we will move this, and we will copy this to there. The number of times, I think we just gonna use copy. So just once. Oh, we forgot to copy this one. Copy this one too. So we copy this one, and we can also copy the other one, or we can just use the mirror. Okay. I think I'm gonna use the copy. We change that to -30. Let's select this one, and then this one, -30. Okay. So I think we have the save it. We have the geometry here. Let's check whether we have the geometry correct. Oh, looks like correct to me. Okay. So we have everything here. In order to see whether we created the model correct, if there any discrepancy here, and basically we can go back to the structure and have check any duplicate. So 0 elements have been selected. So there is no duplicate. Do you see any free edge? No, any free edge. Okay, so that's it. So then we are done with the creation of all the elements. So basically we have truss element, and can show the we can also show, and later we can show element type number. See whether we can show. Okay, and can go to the display to show the element type number. As you can see here, all the, let me move this a little bit up. So we have the side girders as beams, inside ones as trusses here, And so now we can start from here to apply the properties, because we haven't yet applied any such as the material, right? So this is just geometry, like a CAD file. Before you do any structural analysis, you want to apply material and the size of them, such as the sectional properties, such as whether they're round shapes or rectangular shapes, or any moment inertial here involved here. So you need to define the properties, right? So now we move to the properties. We wanted to define the material firstly. So So yeah, no material has already been defined here. So we add a material. So we want to use steel, a material ID. We did not do any changes here. So we just make a name here, steel. Probably A36. I don't care about now, but we can keep it over here. We can standard. You can use any standard for the ASTM, such as a database. We have ATC A36. That's what we learned before. So it will automatically give the yield strength. Okay. The yield strength, let's say modulus elasticity, that's in pound per. Okay. So we can change everything to inches. Okay. No. But okay. Anyway, we can check it later. This is a steel that we have already defined. We can close it. This is steel we have already defined. Then we define the sections. So define sections. We move the material to sections. We haven't yet defined in sections. We define sections. Sections here. It would be a general ones. Sections. There are so many different types of sections. So I would leave this to you to do the research which one is which. So here, the first one is very popular or very widely used for steel design because it gives us the standardized shifts for steels. There are also some code formed steels here either. So anyway, let's go. In our case, we are only given the moment inertial or the area of here. We're just going to use the general ones. So here, in that section 90, we just use one and use the general section. So then one, we use the side girder, side girder. So the area, we go back to the area. For the side girder, is 13.2, and moment inertia 350. Right? Oh, that's in feet square. Kind of. It's not. So I just close it. So before I do that, I'm gonna change the unit system. So we have pounds inch, so that we can go back to the material property, or let's say we can just move to the sectional property. So the material is already defined here. We move to the section. We add the side girder. Then you have this is oh no way, it should be here. Side girder. We have the general section. Here we are, 13.2, and moment inertial IYY. Moment inertial should be IYYYZZ. Right? So here the XYZ, that's for the local axis of your beam. So X axis is a longitudinal axis of your beam, and Y and Z, that's the bending axis. So here we use 350 here. And for IZZ, we don't know. We can just use the same since the bending will be on two directions in some cases, but in our case, we don't know which one will control here. We can just input both of them here. Apply, as you can see here, the side girder is created, and then we create the interior truss. Truss is interiors. We use interiors. So the area here is how much? 5.8. 5.8. 5.8. Here, everything here is 0. And consider truss. Apply, everything is already generated here. So that's the sections that we could use. We just close and close. Then we created that, but remember we have to assign the sections that we create. So we go back to the load and that element here. So we change the parameters, such as we wanted to change the section of the outer beams, side girders as the section ID that we defined, right? We have the section ID. So, as soon as you click the change parameters, there is a window on the side for you to use. I think that's pretty convenient. We have the section ID, we assign everything. We have the side girder up here, so we need to apply. But since we haven't yet set any, you will have a message here, and no select element. So we would select the side, so you can select by a window. And so we can select by window from left to right, and or from press Control. We can also right to left, so that everything will be selected. Okay. Okay. So there you need to have the section side girder. Just apply. Okay. We don't know whether it changes a lot. We can check that. We can go back to that display here. We don't want to show the element type. We just want to show the properties. Okay. So the section property name. Okay. So we have that side girder. Everything's there already. Oh. Okay. Some inside ones is also side girder. So we want to do the change anyway. So we wanted to use the interior ones. We select the inside ones. Do multiple selection, you need to the occurred sometimes. Okay, so we have all interior ones selected. We just click on. So all the interior ones are changed. Here. Okay, that's the creation of the model. Actually, so far we have already created a truss with the geometry and the sectional properties. So don't forget to save it. So I have already saved it. So next one, we're done with the property here. There are a lot of cases you can change the properties here, but that's out of the scope of this example. You do the boundaries. We wanted to apply boundary conditions as a roller here, as a support here. The owners will define the boundary, so we need to add some boundaries. So there is there are different types of supports here you can use. Here we just use that when I wanted to add one. So then, for example, here you can add a pin support. So this is a pin support. So we have already defined the pin support. Should be we restrict X and Y, right? So the X, the Y will be so. Oh, we wanted to select load. That one. Oh no. Okay, we selected that node, apply, and so it's applied. And then we wanted to add a zoner. Zoner. So we just wanted to add a zoner here. So zoner, we use string the Y here. Zoner, apply. So we applied both of them, but we don't know whether they apply them, so we can show the support. So support. Just, oh, okay. And so that's all the support we have, or we could just use support by directions. But unfortunately, it looks like um, we accidentally add a support over here, so we need to remove that. Remove this one. Right. Oh, still there. something wrong here. Int, oh, that is I accidentally support. I think that's how I define it. Okay, something wrong with the loader. So in that this one. Probably will just do that one. Looks like it's a pin. It's a pin. But I have to divide the pin here. Everything is redo the support here. Oh, what happened here? Looks like define the support is not this whether or not you want to. Okay, looks like something changes here. Okay, let's double check. Okay, so now only the 110, so that's that 111 means fixed. So that means X and Y fixed. This is Y, only Y fixed. I don't know what happened here, but that's how we do that. So sometimes the software does. We can also check the support by a table. Tables load one. This one is load two is also defined. Anyway, so we are done here and done here. So now we are go to the load. So we're gonna apply a load at the bottom here. So we better to change that to food because that's how much pound. So that's the load is 600 pound for food. So we can just add that load here. So static load. So we're gonna apply a static load. So you can use Midas Gen to create any dynamic load or so note here we only do static analysis. So you need the name. So we just call this name bottom chord load, bottom chord load. Bottom chord load, that's a type. It's data. In the description, we just add it. And so we have already defined a load case. Yeah, because when you do design, you may apply different types of load cases here. This is very convenient for that, fast to use. We have a load case defined, and then we apply the load. So that's going to be an element load, so beam load. So there are other structural load, but here we just apply the element load. As soon as you click the element load, you have the element beam load. Then the load case number is shown here because that's what we have already defined. The load group, you can create some group, but here we can just ignore that. And we have the options to add. So here we have the direction that's in global Y, Y direction. That's value, and we apply the uniform load relatively for the 0 means one end, 1 means the full length on the other end. So the W would be minus 600 because that's in the X direction, and in the Y direction. So we select all the bottom chord, apply the load. The load has already been applied. And you can also show the load here if you're not sure. You can show the element beam load. It's showing there, and then you can also show the load values. And load values showing here at 600 over there, but is that 600? Okay, that's minus 600, and then the unit is in pound per foot. That's all the load we have. We get down here, we save it. So now we can do the analysis. So this is the structure here, To go to the analysis tab. So there are a lot of different analysis here, and we will show them simplest one. Perform analysis. Okay, so let's say you can check one warning message is there, and is successfully completed. Any warnings? Okay. No any warnings so far. I mean, it's analysis option. Okay. So we're done with the analysis, right? So later on, with the progress of your learning, probably you can use nonlinear or p-data buckling. We can talk about that later. So now we can show the results. You go to the results tab from the analysis to the results, and we can show the such as, for example, in structural analysis, you want to show the moment and shear diagrams, right? Because we have side girder, so they should show the shear and moment diagram. So we can, with the forces, beam diagrams, we can show the moment diagram. So the moment, interesting here is Fx, Fy, that's for the local, such as um, for the bending would be about the beams Y or Z. So here we can check the bending about Z here and show the line field. Okay. That's the bending moment. Okay, looks like something wrong. So this is a symmetric system there. So oh, okay, I see why we have a larger bending because I missed one member there. But I better go back. So I just unclock the results and go back to the node that means because it looks like I forgot to add another beam there. So another truss. I'm going to just create another truss that will be. So as soon as we have already defined the material and the name, then we will the section and here. So on the left side, you will see the definition of the element here. So I'm gonna use the truss, create a truss here. Continue from here to here. So we have already created the truss. That's it. Save it. Go back to analysis. The analysis again. Okay, it's done. We show the moment diagram again. Show the moment diagram again. Apply background. So that should be MZ, right? So when we talk about Y and Z, Y is a vertical, Z is a perpendicular. Apply. Right? So that looks more reasonable, right? That's a moment diagrams for the side girders there, and you can use that to make it more readable, or you can show the values. You can show the values. We do not use that contour. I can show that. So values there. So everything is there. So it's in pounds times foot, or you can change them to kips times foot. To use that's the moment diagram. And you can also show the shear diagram. Sharing should be Fy. A shear diagram was we have already expected. I can also show the axial force. Are there any axial forces? Okay, axial force is also shown, but then we need to uncheck the property name because they are in confliction with the. So that's the axial forces. You can see the axial forces. So please be aware of the unit system for here. So all these numbers should be in kips here. How about the interior ones? I can also show the forces in the interior ones. That should be truss forces. Truss forces should be, can show them So truss forces on both ends are shown, so we can just show the maximum. So that's the truss forces. We do not show the contour. So as you can see here, some of them has zero, like zero force, because such as over here, there is no point node there. So basically, this one should be zero force member, but some of them with very minimum, very small. So due to the calculation errors, this one should be zero, this one should be. So that's the axial forces, Right? So I think that's all about. You can also show the deformations and reactions there, and so there are a lot of icons there for you to show the different responses here, including reaction forces, internal forces, shear diagram, moment diagram, or any deformations here. I think that's, I'm going to leave that to you to explore the results modular. I call the modular or results interface here so that you can make a full use of the Midas software here. I think hopefully you would enjoy this. I think that's all for this introduction here. Thank you. I'm gonna stop sharing and stop record.